Hello, so today I'm going to be solving a problem where we have to find the resultant of the forces. So I'm going to be finding the magnitude of the resultant as well as the vector form of the resultant. So my preferred method to solve this is by writing the forces as vectors and then adding them and finding the magnitude that way. So I'm going to show you guys my preferred method for solving this, which will actually come in handy later on if you're taking statics. So I'm going to call F1, I'm going to call 900 newtons F1. And the vector F1 is equal to 900 cosine 30, the horizontal distance, and then I plus 900 sine 30. And so we end up getting F1, vector F1 equals 779.423i plus 450j and then for F2 we have F2 equals 600 newtons, and the vector F2 equals, so for the angles it's going to be 30 plus 45, so we're going to have 75 for theta, and so this is going to be 600 cosine 75 plus 6, oh, and I almost left out the, sorry about that, I almost left out the I. Plus 600 sine 75 j. And so we end up getting for this one we end up getting 155.3i plus 579.55j. And then now that we have this guy and this guy here, I'm going to make a table so that we can sum the x and y components of the vectors to get the resultant. So here is going to be my table. This is going to be step 2, I guess. So we have fx and fy. And we have f1 and f2. And so we're going to put these values into this table now. We have and so now that we have these in place here, and sorry if that's hard to read, it's a little tight in there. So now we're going to get for the vector r, the resultant vector, we have (934.78) and 1029.56. So the resultant vector equals 934.78 pi plus and now to find the magnitude of r, we're just going to put that into the formula for magnitude. So magnitude of r just equals the square root of rx squared plus ry squared. And so for this we end up getting so the answer that I ended up getting for this was magnitude of r equals 1,391 newtons. And now the last step is to find the angle at which that force is directed, the resultant force. So the way that we can find that is we just use this formula. Tangent theta equals ry over rx. And so theta equals inverse tangent of ry over rx. And our ry is 1029.56, and our rx is 934.78. So then for theta, when we put that on our calculator, we end up getting 47.8 degrees. And so our final answer for this problem is going to be 1,391 newtons. And then some people like to draw like which quadrant that force is directed. So that's how I would write the answer for that. So thanks for watching. I hope this helped you guys, and good luck.